Hello guys, welcome to another tutorial. Now in this tutorial we are going to discuss the basics of QGIS. Now as you can see from the title, it's an absolute beginner's guide to QGIS. Now if you have been looking for an open source option to Esri's ArcGIS, something which could offer almost the same level of functionalities or capabilities, which does not really require a subscription of let's say hundreds of dollars, then I guess you don't have to look any further. QGIS is definitely your solution because QGIS offers a wide array of functionalities just like ArcGIS, and sometimes the functionalities can even be better because of the immense flexibility that we have with QGIS. So as I said, if you're just diving in to perfect your QGIS skills, this tutorial could be an excellent introductory tutorial. So stick around with us to see what we are going to discuss in the coming few minutes. Now these are the major things that we will be discussing in this tutorial. First I'll be showing you how to install QGIS, and then I'll give you some sort of an introduction to the general interface, the QGIS interface. Then we will discuss how to work with the vector data in QGIS such as Shapefiles. Also I'll show you how to install an additional plugin such as OpenStreetMap, and then we will discuss how to work with Raster Data in QGIS. And finally, before wrapping up the tutorial, we'll try to create a map using QGIS which can be in a publishable quality. And the things that we're going to discuss today is going to be sufficient for you to just get started with QGIS. And of course there's going to be a lot more to explore, and from time to time we will also be publishing QGIS related videos in this channel. So if you're looking for a good starting point for QGIS, then you guys don't have to look any further. So if you haven't subscribed to this channel yet, then it's a good time to just go and click on that subscribe button so that you will be updated instantly whenever we upload a new video on this channel. So without further ado, let's go ahead and get started with the tutorial. So first, in order to download QGIS, this is the website that you have to come to: www.qgis.org/en/site, and from here you can go to download now, and in here you will see different options that we can actually download from. Now if you're using a Windows PC, you can definitely look into these options which are under download for Windows, but if you're using Mac or Linux, you can actually just have a look at the other options as well. Now since I'm using a Windows machine, I will go here. Now what we're going to do is we're going to install QGIS as a standalone software. So you can either go for the latest release, which is apparently richest on the features. Now as of today, the latest version of QGIS is 3.14. As you can see over here, QGIS 3.14 Pi version was released on 19th June 2020. But if you're looking for something much more stable, they also release a long-term release, which at the moment happens to be version 3.1. Now, I would usually go for the long-term release, the more stable version, but for this tutorial, now let's go ahead and download the latest release, which is richest on features. Now, I'm using a 64-bit PC, so I'm going to go ahead and click on this QGIS standalone installer version 3.14, 64-bit, and after that, the downloading process will begin. Once the file is downloaded, you can just click on that to begin the installation. Yes, now as you can see, the version that we downloaded is QGIS 3.14, the Pi version, which is the latest version as of today. I'm going to agree for the terms, and the destination folder, I'm just going to leave all of them as default. And over here we have the option to download some datasets that we can actually work with if you're just getting started with QGIS, but I guess the datasets that we will be providing through this channel, through our tutorial, will be equally good for your specific tasks for the tutorials that we are going to discuss. So I guess we don't necessarily need to tick these because we won't be needing those datasets in any case. And we can just go ahead and click on install, and we'll click on finish. Once the installation is done, you can simply go to your start menu, and you will see that it appears over here, QGIS desktop 3.14 with grass. I'll explain to you guys what this grass is in a future videos. Alright, so I'm going to click on this. So if you're just getting started, you can simply go to this new empty project. Either you can double click over here, or you can even click over here, this new project, or you can use the keyboard shortcuts Ctrl+N in order to begin a new project. So I'm just going to double click over here, and that'll bring up an empty working space for us. So this will basically be our working interface of QGIS. Now let's get to know about these panels a bit before we proceed on to the further steps. Over here you can see the browser panel. Now as you can see that there are multiple options under this browser panel. Now basically as a beginner to QGIS, you'd be using this browser panel quite frequently in order to just navigate to your data. For example, you can see it shows you the drives over here, C, D, E, F. So let's say if you have kept your data inside this one of these drives, you can just double click over here like this, and from here you can actually navigate to the place where you have saved your data. Now for this tutorial, as you can see, the first option, Absolute Beginner's Guide to QGIS. And if I go to data, you can see that I have two files called raster and shapefiles. Now let me go ahead and open these shapefiles. And as you can see over here, we can navigate to the files through this browser just like that. Now if I were to open those files separately, I have navigated to the same folder location, and inside data you can see that we have two files, shapefiles. These are actually the files that you see over here. So just remember that if you want to navigate to the place where you keep your files, or just to access them quite easily, you can simply use the browser panel. Now in case for some reason if the browser panel is not active in your working space, you can simply go to View and Panels, and from here you can activate the browser panel. Now if I click on this, it will deactivate the browser panel. I can go to Panels and activate the browser panel. Now in case if you're let's say if you're dealing with loads of data, then it would be handy to actually have a second browser panel, sort of a copy of the first browser panel. So that's what has been enabled for us through this browser within brackets 2 option. That'll kind of create a second panel, an equal second panel, from which you can actually access maybe a different folder or a different database that you have kept your data in, and then drag data into your working space quite easily. So for us, since we are just getting started, I think just one browser panel would be sufficient. So I'm just going to go ahead and close this. And next is the layers panel. Once you import the layers which we are working with into QGIS, all those layers will be appearing in this layers panel over here. Again, if you cannot see that, you can go to View, Panels, and over here you can either toggle on and off the layers panel. And as you can see, there are actually other few panels as well. For example, this GPS information, or if you want to activate another panel like, let's say, advanced digitizing, something like this. So you have the flexibility of switching on and off the panels through this option which I just talked about. So I'm just going to get rid of these additional panels which I added just now. Yeah, I think we better have the layers panel as well. So I'll just go to View, Panels, and keep the layers panel here. And on the right side, you see one panel called Overview, and also we have the processing toolbox. Now this processing toolbox will be used quite frequently for our tutorials, because it contains quite a lot of tools which we can use for different geoprocessing tasks. And similarly, in case if you could not find it here, you can, let's say if it looks something like this, you can again go to View, Panels, and over here you can activate the processing toolbox like this. So that's a quick introduction to the panels. Now similarly, something that we would be equally interested in discussing would be the toolbars. Now what you see over here in sort of a horizontal formation is called as a toolbar. Now I can simply drag one toolbar and drop it over here. So this entire thing is actually sort of a toolbar which has been designed for certain function, certain dedicated function. Now to access the toolbars, to activate or deactivate the toolbars, you can simply go to View and Toolbars. And over here you can actually manage, you can decide whether to show the toolbar or not. Now for example, if you think that you don't want to display this particular toolbar, now the name of this toolbar is QWater. So if I go to this QWater and deactivate that, you will see that the toolbar actually sort of disappears. Now similarly, you can actually show and hide the toolbars, even the major toolbars as well. For example, this data source manager toolbar, it's basically one of the main toolbars that you will be required to have when you're sort of doing basic geoprocessing tasks. So in case if you decide to deactivate that, you can simply click over here and deactivate it. And similarly, you can just activate it back simply by hitting this check button over here. Now we'll discuss in detail what each of these toolbars also actually do for us. But I guess for the time being, the explanation which I provided on the panels and the toolbars is actually quite sufficient just to navigate around QGIS. Alright, next we'll talk about how to work with vectors in QGIS. Now as you can see over here, once I have navigated to the folder which I have saved all my data, you can see that there's one option called Shapefiles. Now again, if I pull up this actual folder which contains all of these data, you can see that we have the shapefiles as a .shp file. If I check the file type over here, it's .shp. But for each shapefile, along with that .shp, there are other files as well, such as this prj file which contains the projection information, and .dbf file which contains the attributes information, stuff like that. But when we open it from the browser panel over here, it actually shows only the item which is of interest to us, which is basically the .shp file through which we can access that particular shapefile. So one of the easiest way to add a shapefile into our QGIS working interface will be to browse through to the place where you have saved your file, and you can simply drag it and drop it over here. Now this is a shapefile which shows one of the areas of interest which I have demarcated for the purposes of this tutorial. And as soon as I added the layer, you can see that on this layer panel, this area of interest layer sort of got added into the layers panel as well. Now, if I hover my mouse over this, you can see that it shows some information. It shows the location where the file has been saved. Apart from that, it also shows the projection, the current projection which the file is in, which is EPSG 4326. And if you would like to know a bit more information about this, what you can do is you can right click over here and go to properties. And from here, just click on information in case if it's not already activated. And this information from provider is basically some basic information that you have about this particular shapefile. Now you can see it's an S3 shapefile, and it's of geometry polygon, and the coordinate reference system is EPSG 4326, which is the WGS 1984 geographic coordinate system. And also it shows the extent in terms of decimal degrees, as you can see over here, and also it shows the path where the file has been saved. Now, in addition to this polygon shapefile, I can also add other shapefiles such as this hospitals. Let's drag it and drop it over here. Now that shapefile is of the geometry type point. Now if I again right click and go to properties, you will see that the geometry type is point. But apart from that, the other information such as the coordinate reference system and also the path and also the storage type, it's all the same. Now in case if you would like to change the color of these points, you can see that now it appears in sort of an orange color, which is quite similar to this color by which the area of interest has also been displayed. So to change the color, you can again go to properties of the layer, and you can go to symbology. And over here you can see that under this marker option, we can select on this simple marker, and from here you can select the color that you want. Now let's say I want to select something like a shade of a blue, so I'm just going to adjust the color panel in such a way that I can actually select corresponding shade of a blue for my point, and then click on apply, and you can see that in the background, as we click apply, the settings get applied immediately. Now there are other functionalities that you can actually play around with as well. If you select on this heading marker, you can see that there are actually other types of markers also that you can select from. You can see that since we're talking about hospitals, we can even opt to use this topo hospital marker as well. If you click on this one and click apply, you can see that the icon changed to a standard icon which is used to depict hospitals. Alright, I'm going to revert it back to maybe black dot and maybe select the color of the dot manually, something like this. And also if you think that you need to increase the size of this dot, you can simply increase the size like this, or you can decrease the size like this. Click on apply and you can click OK. Now another thing that you might be interested in knowing is actually what each of these points refer to. Now one of the easiest ways of knowing that would be simply to go to that particular layer and right click and go to the attributes table. Because this attributes table is the location where all the corresponding data pertaining to each of these different attributes have been saved. Now if you're getting these shapefiles from different sources, now there's a good chance that those sources might include the corresponding attributes in a very descriptive manner. Now that depends on your data source. For this example over here, you can see that it shows the name of the hospital over here and the city. Now if you would like to know which point corresponds to which, what you can do is you can simply click on one of these attributes like this, and that'll sort of highlight. Now over here it might not be that apparent because the highlighting color is actually yellow. So when I click on this London Welbeck Hospital, you can see that hospital over here, the point over here gets colored in, sort of highlighted in yellow. Now if I click on the second one, you can see that this second particular point got highlighted. Similarly, the third one, fourth one, St. Mary's Hospital, and the fifth hospital over here. And you can also highlight multiple hospitals. Let's say if you want to just have a quick look where Cromwell and Grand Union Health Center is, so you can just hold down Control and select item number 3 and 5. so that you can see that those selected items actually got highlighted over here. Alright, so in order to deselect everything that you have selected, all the attributes that you have selected, you can simply use this deselect all features from the layer button, and that will deselect everything just like so. Similarly, if I go to this area of interest and go to this attributes table, let's see what it says. Yeah, it just says that it shows the ID number and the description, which is the area of interest, and just say it's in London under the city column. So we have another shapefile to import. Let's say if we want to import this major roads, we can simply drag it and drop it over here. Now again, as soon as we import, you can see that the line is actually not that apparent. You can use your mouse wheel to scroll in or to zoom in or out. Now if you scroll up, you will see that you will zoom in. But if you scroll down, you will see that you will zoom out. But similarly, you can use this zoom in button actually to highlight the area to which you would like to zoom into, like this, or you can do it a bit better like this. And you can switch back to this pan tool just to pan it around. Coming back to the thing that we discussed on the major roads shapefile over here, you can see that the file is, the line is actually not that apparent. So what I can do is I can go to this major roads and go to properties, and select under symbology, select this simple line over here, and I'm going to assign, let's say, black color for the line, and I'm going to increase the stroke width to maybe about 0.66, and let's see how that looks. Yeah, you can see that now the line which corresponds to the major road is actually quite apparent now. Or if you would like to actually add a different style, you can add maybe a different style from here as well, but for me I think this styling would be sufficient for the purpose. After that, I can go to the attributes table and have a look at the attributes as well. Yeah, it shows the name of the city, which says Bayswater Road, and city is in London. Now you can see that in QGIS we actually work with layers. We still can do the things that we would normally do when we are working with layers, such as swapping the position of the layers. Just see what happens when I select on these major roads and hold my left mouse button, and when I drag it down and release it, you can see that the major roads shapefile actually went behind this area of interest, and it's not visible anymore because now it's behind this area of interest. Now if I deactivate it using this check button, deactivate the area of interest, you can see that the layer is actually behind. And similarly, if I push this hospital below this area of interest layer, you can see that St. Mary's Hospital, which was over here, now actually disappears because that layer is behind this area of interest. Let's say that if I got rid of this fill color for this area of interest, I would still be able to see everything, isn't it? So we can still do that simply by going to properties. Now over here, just keep in mind that we are working with a polygon item. So we can go to simple fill over here, and over here symbol layer type, under symbol layer type, just go to outline and simple line. So that means we are going to specify only an outline but not really a fill color. And the outline, let's say I'm going to specify a certain color which I would like to have for the outline, and maybe increase the thickness a bit. And when I apply, you can see that the fill color sort of got disappeared, and instead just the outline is retained. Now it shows our area of interest and some locations of some hospitals, as well as the extent of this major road as well. Alright, now let's learn how to add some labels into our workspace. So if you can recall the attributes table of these hospitals, if I open it back, you can see that it contained the name of the hospital under this column name. So it would be actually quite useful if we can actually display those names in this mapping interface as well. And that's quite simple. You can go to the particular layer. Now if I want to display the name of each of these hospitals, you can select that particular layer from here, go to properties, and over here you can go to labels. And right now it's saying no labels because, as you can see from the map, there aren't any labels that are getting displayed. So I'm going to go and select single labels from here, and we have to select the particular value. Now again, if I open back the attributes table, let's close this and go to attributes table from here, you can see that the corresponding name of the hospital is under this name column. Now this is the value that we are going to actually choose, because if we select, let's say, city, all the labels that appear will contain the name London, but that's not what we want. We want the actual name of the hospital. So which is under this column name. So I'll go to properties again and go to labels, select single labels, and from here select the column name under which each and every name of the hospital was contained in. And from here you do have some text options as well. You can actually go ahead and select a different font from here, and you can select different styles. Now, but for the time being, I'm just going to actually stay with the default text. And after that, when I click apply, you can see that the name of that corresponding hospital actually appears right beside the point feature over here. Now, if I would like to increase maybe the size in terms of the text, you can go to this size, and also you can change the font color if you wish to. Let's say we will go with red color and click on apply, yeah, and click on OK. Now you can see that we quite easily managed to add the name of the hospital into our mapping interface as well. Now you can do the same thing for this road shapefile as well, but I guess you got the basic idea of how to do that. So I think this is good enough for the time being. I've told you guys so far that we are working in an area which corresponds to London, because that's what we got to know from the attributes table. Now, wouldn't it be nice to actually have some sort of a base map, let's say something like an OpenStreetMap, which we can use in order to add as a base layer, so that we can know geographically where our area of interest is placed at, and also where exactly these hospitals are sort of located with respect to that base map. Now in QGIS, one of the easiest ways of adding such a base map is to add an OpenStreetMap through the external plugin called Quick Map Services. Now I think you'll get to know when we actually proceed with much advanced geoprocessing tasks using QGIS that the fresh installation of QGIS sometimes not necessarily might include certain functionalities that we might need in order to get our work done. So that's the point where we turn our heads into external plugins. Now the reason why QGIS might not come with all the external plugins installed in it is, for starters, it'll be actually a waste of space because we will be using those additional plugins only for specific tasks. Depending on the task that you're trying to achieve from QGIS, it's better to actually just go ahead and download that particular external plugin from the repository. Now, for example, since we are trying to add an OpenStreetMap base layer, one of the easiest ways to do that would be to first go to Manage and Install Plugins over here. And from here, we will search for Quick Map Services. In this plugins window, you see that we have the options to see what are the installed plugins and what are the not installed plugins. But for the time being, let's go ahead and search for Quick Map Services. And you can see that we have one option called Quick Map Services, which we can directly install into our QGIS, existing QGIS interface. Now you have some sort of a description over here and some information about the author. This plugin was created by NextGIS, and what we can do is we can simply go ahead and click Install Plugin. And while you do that, just make sure that you have a functional internet connection, so that it will download the corresponding files for us. And just in a matter of seconds, it will install the plugin for us. After that, we can just simply close, and then you can go to Web Quick Map Services, which you just installed, and go to OSM over here, and you can select the OSM standard, which is the standard OpenStreetMap. And as soon as you do that, you will see that it will place the base map behind our area of interest. And from here, you can very easily see that now we are working in an area which is quite close to Hyde Park. We can just move the map around and see. And this sort of confirms that our area of interest is actually correct. You can see that area of interest has been demarcated somewhere around the boundaries of Hyde Park, as you can see over here, along with an additional area over here. And one of the cool things is that this OSM standard map that you just added is not only for the area of our interest. It's in fact not only for the country that we are working in, it's for the entire globe actually, as you can see over here. If you want to zoom back to the place that you are working in, one of the quickest ways that you can do that would be to go to your particular layer, right click on it and select zoom to layer. And as you can see, it took us back to our area of interest. One more thing to note is that the current coordinate reference system of the project. Now if you draw your attention to this lower right corner, you can see one EPSG code. In this case, the EPSG is 4326. That's the WGS 1984 Geographic Coordinate System. Now, for certain cases, depending on our requirement, we might actually change the coordinate reference system. Now in this tutorial, I'm not going to go in deep and talk about the different coordinate reference systems because that's actually a topic on its own. So I'm going to reserve one specific video probably in a couple of days only for that matter, only to talk about the CRS, the projections and that sort of thing. But for the time being, just understand that right now your layers and your project both are in the same coordinate reference system, which is WGS 1984 Geographic Coordinate Reference System. And this is how the OpenStreetMap looks under that particular coordinate reference system. Now, in case if you would like to have sort of a clean top view of the map, one of the most commonly used projected coordinate reference system is the Web Mercator Auxiliary Sphere Coordinate Reference System, especially for base maps like this. So what I'm going to do is I'm going to go ahead and click on this button over here, and that'll open up the project properties for me. And under that, I'm going to select the CRS, which is the CRS of the project, not the individual layers. And I'm going to search Web Mercator Auxiliary Sphere. As you can see over here, it already appears either here or even you can see under the predefined coordinate reference systems, WGS 1984 Web Mercator Auxiliary Sphere. This is the coordinate reference system that I'm going to actually like to activate now for my project. And when I click apply, you can see that now the view actually changed a bit. Now it's sort of a more clean top view, which we can use to very easily visualize without that tilt that we had with the previous coordinate reference system. And now even you can zoom in and quite easily see what sort of streets that we have within our study area, within our area of interest, as well as beyond our area of interest. And you can see different elements now within this Hyde Park area as well. Alright, so far we made use of certain shapefiles which were sort of provided to us. Now in this tutorial, I'm providing these shapefiles to you guys. So for you, I'm going to be the source. So for you guys, these shapefiles were provided to you by someone else. Now what if you want to create your own different shapefiles? Now for example, let's say I want to create some elements that covers or some shapefiles that cover these water bodies within the Hyde Park itself. Let's say when I zoom over here, you can see there's one round pond over here, and we have the serpentine over here, and we have the long water over here. And if I zoom in a bit, you can start seeing that there are how many? 1, 2, 3, 4, 5 small sort of pond kind of water bodies as well. So if I want to create maybe different shapefiles for each of these different water body, or just create one shapefile which has polygon elements, which also will contain all of these attributes as well. Now, how can we create such a shapefile? That's what we're going to talk about next. Now, especially when we have a base layer like this, and when we try to draw on top of the elements that we can see on the base layer, we call that process as digitizing. So right now what I'm going to do is I'm going to use this OpenStreetMap as my base layer, and I'm going to digitize. And through digitizing, I'm going to create a number of polygons, which I'm going to attribute to each of these different ponds, and through which I'm going to actually create one shapefile called ponds, water bodies in Hyde Park. So that's sort of a way of creating new shapefile, new polygon shapefile, new polygon, line or point shapefiles. Doesn't matter which one you need, you still can make actually all of them depending on your necessities. Now, as I said, for this example, I'm going to create polygon shapefiles which corresponds to the water bodies near Hyde Park, as you can see over here. So the way to do that would be, you can go to layer and create layer, and you can create new shapefile layer. This new shapefile layer dialog box opens up. You can provide a name for your file just to proceed with, but if you would like to actually make your shapefile sort of a permanent one, not in terms of its attributes, but just in terms of the shapefile being a permanent shapefile, you can actually save the file in the same time into the place that you would like to save it to. As you can see over here, I have navigated to the same folder which I have kept the other shapefiles, and now I'm going to go inside the shapefiles folder, and I'm going to create one shapefile called let's say water bodies. And this file type, you can see that by default it's s3 shapefile.shp. Alright, now the file encoding, you can keep it as UTF-8, and the geometric type. Now, if I'm trying to pinpoint certain things, I would be just adding points, isn't it? So in that case, the geometric type which I should be selecting is point. Now, if I'm trying to digitize maybe a road, something like this, or maybe these small footpaths inside the park, a much better way to do that would be to add lines. But now, since I'm trying to cover an area in space, cover the ponds, I'm going to select polygon. Alright, and the coordinate reference system, you can keep the QGIS 1984 coordinate reference system like this. And over here we have the attributes, the things that we would like to include in the attributes table. Now by default there is one item called ID. I'm just going to select it and get rid of it because we don't really need that. When you're normally creating, let's say, different ponds, one thing that you will have for sure is the name of the pond. So I'm going to create one attribute called name, and then we have to select what sort of data it's going to be. Now let's say if I put something like area, then the data is going to be in terms of maybe decimal numbers or a whole number, isn't it? But when I'm specifying a name, my data type is going to be text. So that's why I'm going to select text over here. And the length, actually you can select the number of characters to be any number over here, but as you can see, it's not going to go beyond a certain number of characters. But just to be on the safe side, maybe I can put something like 100, so that that particular text box will allow 100 characters to be filled in. And after that, after you're done with this, you can add to the field list. Alright, so apart from the name, I can maybe add something like the location, because we know that all of these are actually located in London, but it would be actually good to add another column called location, and that's also going to be text data. I'm going to leave it as it is, and maybe I can select each item by a number. Let's say item number 1, item number 2, 3, and so on. Maybe I can create one more column called item, and instead of the numbers being text, I can actually make the numbers to be whole numbers, isn't it? So I'm going to select whole numbers, and the length, yeah, I'm going to select it as 10, because over here we just have around how many? 1, 2, 3, 4, 5, 6, 7, 8, about 8 items. So I'm going to keep the length to be 10, and I'm going to add that into the field list as well. Alright, from here I'm going to click OK. Now you can see that it created for us a new layer called water bodies over here, which does not really make anything appear on our map, because this do not have any attributes. If I go to the attributes table over here in water bodies, you can see that it's just the 3 columns which we created, but at the moment we do not have any attributes. And by digitizing, what we are going to do is we are going to create different attributes. Now this by itself is actually a shapefile which you just created, but an empty one. You can again go to properties and maybe assign a proper color for that. You can go to symbology and simple fill. Maybe you can assign something like a lighter blue, because now we are talking about water bodies, isn't it? So I can select apply, and the stroke color also, I can maybe put the stroke to be a bit of a darker blue, so that whatever the shape that we create, it'll sort of appear in this manner. As you can see over here, they show an example over here how it's going to appear. Now let's see how we can get started with digitizing and creating new attributes to our shapefile. What you can do is you can simply right click over here and select toggle editing. Alright, when you do that, you can see that even the button that's over here in this toolbar gets activated. That means right now you're in the editing mode of that particular shapefile. Now the way to add attributes would be, you can go to this add polygon feature over here, and you can see that your mouse cursor actually changes right now. So you can zoom into the place that you would like to digitize, and you can use your mouse button to scroll in or out. And after that, what you can do is you can simply start drawing by first initiating your clicks by clicking on the left mouse button, and you can draw like this, covering your area of interest. So now what I'm doing is I'm just basically digitizing the round pond over here like this. Well, you can always zoom in and out and try to be more accurate with your digitizing work. Yeah, once you almost reach the end point, you can right click on it to sort of wrap up your digitizing work, and that'll open up these 3 items that we just created. So I'm going to provide the name as the round pond, and the location is going to be London, and the item, this is item number 1. What happens if I try to add some text over here? Instead of adding the numeric number 1, if I try to type 1, you can see that nothing happens, because this doesn't accept any text characters. It only accepts numerical values, and even among numerical values, it'll accept only the whole numbers, because we selected the type to be whole numbers. For the time being, I'm going to stick with 1 because this is the first item that we digitized. So and you can click OK. And now you can see that the corresponding attribute appeared over here. And if I go to the attributes table, you can see that now we have one attribute, which is the round pond. So similarly, just keep in mind that you are still in the editing mode, so you can actually proceed with the other digitizing work as well. So I'm going to digitize the serpentine now in a similar manner. Again, you can be quite precise and accurate when you do your digitizing by zooming in and out, but since this is only for the purposes of demonstration, I'm just going to sort of run through it fast. Yeah, once you're done, you can right click on it and add the name. Serpentine. The location is going to be London, and the item, this is item number 2, which we digitized. Alright, if you zoom out, you can see that the two attributes which we digitized just now, the round pond and the serpentine. Now I can proceed with the third item, which is the long water body over here. Start digitizing just like we did for the previous cases. And when you need to do it more carefully, you can always zoom in. Alright, now I'm going to make a mistake on purpose so that I can see how you guys can correct it in case if you happen to make a mistake on the way. I put my vertex somewhere over here by mistake. Alright, so don't worry much, just continue digitizing as you would normally do for the other parts. And once you're done, you can add the name, the long water, location is London, and this is item number 3. Alright, now I can see that we have the 3 items, but with an error over here, which I'm going to show you how to correct. But before that, maybe let's proceed with the other 5 water bodies as well. I'm going to name these 5 items as pond number 1, 2, 3, 4 and 5. So this one is going to be pond number 1. Location is same, and this is item number 4. This is pond number 2 and item number 5. And this is pond number 3, item number 6. This is pond number 4, item number 7, and there's this small pond over here. This is pond number 5 and item number 8. Now, in order to make your edits permanent, you can actually save your edits. The way to do that would be just click on this toggle editing mode button again, and then it'll ask, do you want to save the changes to the layer water bodies? And of course, yes. And now it's a permanent set of attributes which we have inside this water bodies shapefile. If you go to the attributes table, you can see that we have the different attributes over here. If I want to know pond 4, when I select, you will see that it sort of gets highlighted in yellow. And if I want to know what the serpentine is, you can see that it gets highlighted like this. Alright, so to deselect everything that was highlighted, I'm going to select over here. And now let's get back to this issue that we created over here by digitizing one wrong additional point. So to turn back this into an editing mode, you can simply right click and then toggle editing mode again. And from there, you can select the attribute which you would like to modify. Now, in order to do that, you can again open the attributes table and you can select, in this case, the long water is the attribute that I have the issue with. So I'm going to select long water like this. And then you can go to this vertex tool and select on that. And now you can see that it gives us access to these different vertexes. So what I'm going to do is I'm going to simply click on this point. And you can see that when I click on that point, it actually gives me the freedom to move that point around. So that point should be somewhere over here. I'm going to move my mouse cursor to the point where it's supposed to be. Left click on it. And you can see that it actually moved like that. Alright, once you're done with that, you can simply again click on this toggle editing, just like what we did before, and you can save the new edits so that now you have the boundary of the pond to be actually the correct boundary. Now to deselect this item, again you can go to the attributes table and deselect the items like that. And in case if you would like to see the boundary with respect to the real base map, one way you can do a quick check would be to decrease your opacity, as you can see over here. And when you click apply, you can see that the transparency sort of increases, isn't it? And from there you can see whether your digitized file is properly overlaying on top of the base layer or not, on top of the boundaries of the corresponding attribute in the base layer or not. So that's a quick way of actually doing your check. Even you can increase this transparency by decreasing the opacity while you're doing the digitizing process as well, so that it'll be much easier for you guys just to draw on top of the exact boundary of the corresponding attribute on the base layer. Alright, now you have successfully created a new shapefile like this. Now if I navigate back to the place where I normally keep my shapefiles, you can see that a new bunch of files which corresponds to water bodies has appeared over here, because when we create a new shapefile, it's not only the .shp file which gets created, but there will be different files like this dbf, the database file, the projection file, and a bunch of other files which is required for the shapefile to actually properly function. So all of that gets created when you create this shapefile like this. So that's pretty cool, isn't it? Alright, so far we talked about working with vector data, and the type of vector data that we discussed today was shapefiles, which is actually quite often used when we are doing the geoprocessing tasks. But there are other different types of vector data as well. But during the course of this tutorial series, we will obviously be discussing many of those other types of vector data that we encounter day to day when we are doing our GIS related tasks. Now let's move on from vector data to raster data. You can see that inside this raster folder I have one raster which is digital elevation model. As you might know, a raster is formed by a collection of different pixels. Now if I drag this and drop it over here, you can see that, and maybe for the time being I'll deactivate these other items like the major roads and the hospitals and also the water bodies. I'll only keep my area of interest. Now as you can see over here, this is one of the tiles of digital elevation which comes in the form of a raster which I have downloaded for covering my area of interest plus much more. This raster data actually is from SRTM, Shuttle Radar Topography Mission. So each of these pixels, if I zoom in, corresponds to a particular elevation value. So that's why this whole thing is basically a digital elevation model which shows the variation of the elevation across the tile. Now if you draw your attention to over here, the lowest value means the lowest darks are corresponding to -7 below the mean sea level, and the lightest values, let's say the whites, are corresponding to 276 meters above the mean sea level. So between that, different color variations can be attributed to different elevations. Now this might not be a proper way to sort of visualize the different elevation ranges of a raster. So those are the things that we are going to actually talk about in this introductory tutorial. So again, similar to the way that you added shapefiles into your working space, you can just navigate to your raster file and drag it and drop it over here in order to add the raster into your working space. Now you can see that this raster is actually a .tiff file. I can similarly go to the properties of the particular file, and if I go to information, you can see that the data type is GeoTIFF and the coordinate reference system is WGS 1984, EPSG 4326, the same coordinate reference system, and some other information as well. And over here you can see one item called pixel size. Now you can see the pixel size is actually equal in terms of the X and Y direction, but these values are quite small because the unit right now is in decimal degrees. But if you were to sort of transfer the unit into meters, you will see that the pixel value is 30 meters by 30 meters pixel. So this raster is sort of a formation of different individual pixels, as you see when I zoom in like this. When you're working with geospatial raster data, there might be other types of raster data as well. For example, if you're talking about maybe land use or land cover types, those can usually come in raster data as well, because the distribution of land cover or land use type can be quite precise and detailed, so you can represent those in terms of different pixels. So for this example, I'm just going to discuss only a few things that we can actually do with raster data. Of course, things are to be explored more, but since this is only an introductory tutorial, we'll not be going that much in depth. But the basic things that we are going to discuss will be good enough to get you prepared in order to discover those advanced functionalities as well. So the first thing that I'm going to discuss with you guys is how to change the color distribution of this particular raster. You can see that this raster is also added, the digital elevation model is also added as a layer. So I can, if I just try to push my area of interest on top of this, you can see that my area of interest is actually somewhere over here. And if you would like to get a quick idea of the elevation distribution of within my area of interest, what you can do is you can go to the select tool, identify features, and you can right click somewhere over here. And you can say that I want to click on not the area of interest, but I want to click on that particular pixel of the digital elevation model. And you can see that the pixel value that I clicked on is 26. So that's 26 meters above the mean sea level. Now if I click on maybe a bit of a darker area like this and select digital elevation model, you can see that that value is 14, which is quite a low value. But if I select maybe one of these lighter spots, let's say if I select on this pixel and select digital elevation model, you can see that that particular thing should be popping up a little bit in reality, because the elevation is 50 meters over here. Alright, so that's the way to sort of inspect each pixel. Now if I want to sort of change the whole color distribution, what you can do is you can right click over here, go to properties and go to symbology over here. And by default it should be, the render type should be single band gray, but we want to use single band pseudo color. And from there you can see that we actually have a wide array of different color ramps to choose from over here. And if you see all the color ramps, you can see that actually there are, let's say if I go with the spectral color ramp, it splits the elevation into sort of a certain number of classes, which you can choose from here. You can either go continuous or you can select equal interval, in which case you will be actually able to determine the number of classes that you would like to split the whole thing into. Let's say I want to have 20 classes with equal interval, and then I can click apply. And then you can see that based on this color distribution, we will be able to sort of interpret the elevations of different areas. I can click OK and I can expand this, and you can see that we have sort of the legend over here. Maybe let me adjust this a bit. Yeah, you can see that this dark red areas are going to be these lower elevations, and these dark blue areas are going to be the higher elevations. And in between these, let's say if I want to know quickly what is the elevation of this particular yellow color area, I can refer to that. It should be about 127. But if you want the precise pixel value, what you can do is zoom into the correct location, and you can right click over here, select digital elevation model, and you can see the elevation is in fact 127. So what we saw over here is actually quite matching. Now if you want to select a different, let's say different styling, you can go to properties, and if you want something much more than what you can see over here, you can even go to this create new color ramp, and from here you can select catalog and click OK, and this will open up some other different ramps. Now since we're talking about topographical data, I can select one of these color ramps, or even you can select these other color ramps as well. Let's say I'm going to go with this one. The name of the palette is BCYR, and I'm going to select OK and select apply. And now you can see that the lowest elevations are actually in dark blue color and the highest elevations in red color. In case if you would like to invert the color distribution of this ramp, you also can do that simply by opening up this and select invert color ramp, in which case lowest elevations will be attributed the red color and the highest elevation will be attributed the blue color. Well, I'm going to flip this back to what it was before, so I can invert it again and click on apply and click OK. Alright, now let's imagine that you actually don't want to have this entire tile of the SRTM digital elevation model. I only want to know the elevations maybe, let's say, within my area of interest. So one quick way of knowing that would be to actually clip this raster by the boundaries of this particular polygon that we have. Now this is the time that we are going to actually make use of our processing toolbox. We can simply type clip over here, and you can see that we have the option to clip the raster using a polygon. You can go to this under GDAL over here. You can select clip raster by mask layer, and from here you can input the raster, which is going to be my digital elevation model, and the mask layer is now going to be my area of interest. And over here you can actually select the clipped raster into a particular location, but if you don't want to do that at this moment, you can actually save it as a temporary file as well. And you can now simply click run, and after a while you will see that algorithm clip raster by mask layer finished. And after that you can close it, and now you can see that it created for us a new layer called clipped, which is over here only to our boundary of interest. Now what you can do is you can simply go ahead and deselect this entire tile, so that you can see that now we have the elevation model covering our area of interest, just only the area of interest. As I told you, this is not a very high resolution digital elevation model. That's why when we start zooming in, you actually start seeing the pixels, because each of these pixels will be representing one particular uniform elevation value. If you're working with, let's say, very high resolution data like LiDAR data or IFSA data, that means even when you zoom in, you will still actually not start seeing pixels, because the pixel distribution will be very fine and it will sort of look like a continuous layer. But that's not an issue for our tutorial over here. Now again, what you can do is you can see that now the clip mask means the elevation distribution within our area of interest only ranges from 11 to 59. Now again, this is not actually a proper color distribution, so what I can do is I can do the same thing which I did before. Go to symbology, go to single band pseudo color, and from here go to select create new color ramp, go to catalog, and from here I'm going to select the same BGYR palette. Maybe I can split this into a number of classes as well. I can select equal interval and maybe split this into, let's say, 10 classes. Apply. Yeah, now you can see the color distribution actually changed, and click OK. And now if I open this, you can see that these lower elevations are actually about 11 meters above the mean sea level, and there's a bit of a highland over here. I mean, a bit of a higher elevation area, which is about 59 meters, and in between most of the areas can be categorized as this 27 to 32 class, as you can see from the color distribution over here. So these are the advantages actually of having a color distribution which shows the elevation distribution as well. So you can quickly get an idea about what sort of elevations can be attributed to different geographical areas of your study, of your area of interest. But let's say if you would like to derive a set of contours from this. Now it's very easy to do that using QGIS. You can simply go to raster, and among many raster operations that you can see over here, we are going to go to this extraction and select contour. Now from here, my clip mask is going to be my input layer for this, and the interval between the contours, we can actually set the interval manually. Let's say I'm going to select the interval to be about 5 meters, and after that you can simply run again. Again, just keep in mind that if you want to save this contours shapefile, you can create a new shapefile over here, but if you want to keep it as a temporary file, you can simply run and later decide whether to save it or not. And once you do that, you can see that it actually shows you the contours like this. Now let me go ahead and get rid of this base map over here. And if I want to change the color of the contour lines, I can go to properties, and over here in the line feature, I'm going to actually select maybe black, because that would be more apparent, like this. If I come back and open the attributes table of this contours layer, you will see that we have 3 attributes: the field ID, the ID, and the elevation. Now if I click on this, you can see that each ID has its own attribute number, and this is the column that I'm interested in, this elevation column. So for example, let's say if I select this particular attribute, that attribute is actually corresponding to an elevation of 45. So just like that, you can see the different contour lines have different elevations. Now if I want to display those elevations in the map itself, it would be quite handy, I guess. What you can do is you can go to labels and select single labels, and from here, remember our element of interest, our column of interest is the elevation. That's why I'm going to select this elevation value, and the font size, maybe I'm going to put it down to about 8, and let's see how it looks after I click on apply. Yeah, I think this is good enough. And when I click OK, now you can see that each of the contour lines have been now labeled. For example, if I'm trying to get the elevation around this contour line, you can see that the elevation is about 30. Similarly, I can go to the select tool, and if I select this particular line simply by right clicking over here and selecting the contours shapefile, you can see that the elevation value is 30, which is the same value which gets actually appeared over here for each contour line. Quite useful, isn't it? Similarly, you can see that the elevation of the lake, let's say I would assume this to be sort of the water level, and if I select contours over here, you can see that the level is 15. You can see that from the label which is appearing over here as well, which is 15 meters above mean sea level. Now to deselect the item that you selected, you can go to attributes table and deselect. Alright, now this is the thing which I would like to actually put into a map as the final step that I want to do before we conclude this tutorial. But just before that, I would also like to show you how to save a particular shapefile. Now you created this contours shapefile as a temporary shapefile. Now if you would like to save it as a permanent shapefile in your system, what you can do is you can right click over here and go to export and save feature as, and from here you can select the format. Now the format I'm going to save it is in S3 shapefile format, .shp format, and the coordinate reference system is still going to be the same, and the file name I'm going to select it as, let's say, elevation contours .shp, and after that I can click on OK, and now you can see that it became a permanent shapefile, but the newly exported file do not contain these labels, so you might have to actually maybe get rid of this temporary file and again go back to the property, go to symbology and do the changes which we just did. Go to labels and add the labels like this so that it looks like what it was before. So let's say that if you're using something like Google Earth, it's quite easy to export all of these shapefiles into Google Earth file format as well, which is the KMZ file format. So similar to what we did, we can again go to export and save feature as, and over here instead of selecting S3 shapefile, you can maybe select keyhole markup language, the KML file format, and I'm going to again name this as, let's say I'm going to select a new file folder called Google Earth, and this one I'm going to name it as elevation contours, and I can save it. And I do not want to add that to the map, so I am going to deselect that and click OK. Alright, now if I navigate back to the place where I kept those files, you can see that there's one folder called Google Earth, and if I open that, you can see that there's a KML file over here. So I can actually open this KML file in Google Earth itself. And you can see that we actually managed to sort of overlay our contour lines in Google Earth itself, isn't it? That's pretty cool, which corresponds to our study area. And not only that, you can simply like hover your mouse over this and try to click on one of these lines, and then you can get the elevation value as well, which is 25 over here, and this one, if you can recall, it's 15, yeah, over here. So we can actually do the inspections within Google Earth itself, which is actually quite handy. Alright, so this is some additional part that I just wanted to explain to you guys, so I'm going to minimize this. The final topic that we're going to discuss in this introductory tutorial is how to export this information in the form of a proper map. Alright, so to create a proper map out of the data that you might already have, you can simply go to project and go to new print layout, and you can just give a name, maybe let's say map. So this is the editor where you can actually do all sorts of edits to your map in order to make your map look more visually pleasing and to bring up the quality of the map so that it's actually be of a sort of a publishable quality. So first what you need to do is you can go to add item and first click on add map, and from there you can actually draw a rectangle covering your mapping canvas like this. And as you can see, once you do that, the geospatial data that we have over here will sort of be transferred into this mapping canvas. Now if you want to move this around, you can go to this item properties, first select this box which you just drew and go to item properties, and from here you can select interactively edit map extent. And once you do that, you can move these items around like this, and even you can increase or decrease the scale. So for example, if I put a scale like, let's say 15,000, you can see that the map zooms in. But if I want to, let's say, decrease the value, maybe I can put something like 20,000. Also you can use the scroll wheel to actually zoom in or zoom out like this. But if you would like to do it using a numerical figure, you can always use the scale value over here and change it. But now I'm going to add some more additional things to the map as well. So for my case, I would like to actually make the items, or make these geospatial items, to be a bit more smaller. So I'm going to increase the scale maybe to about, let's say, 25,000. Yeah, I think that should be it. And then I'm going to move this to a side, because in this area I'm going to use this area to sort of add a legend, and also add a scale bar, and also add some information like that. So the next thing that I'm going to do is I'm going to add a legend. So in order to add a legend, you can just go to add item, and from here you can select add legend and select it like this. Now by default you can see that every layer which we had before over in the layers panel gets added into the legend, but of course we don't want to have all of that. So what you can do is you can simply select on your legend, go to item properties, legend items. You can simply select the items which you do not want to add into your mapping canvas. So you can hold your shift or control button and select all the items that you would like to actually get rid of. And once you do that, you can simply select this remove selected items from the legend. But as you can see, the button is sort of inactive right now because we have selected auto update from here. So what you have to do is you have to deselect this auto update, and from there just select all the items that you would like to get rid of from the legend, and then click on this remove selected items from the legend. Now you can see that the legend is much more readable. One more thing I would like to do is I would like to actually get rid of these decimal points for these certain numbers. So what I can do is just go back to your QGIS project again, and you can go to properties. And since we do not have many items over here, what I can do is I can simply select this label and actually manually alter the label in a way that you want. Let's say if you would like to keep 2 decimal points at one point, maybe I can leave 2 decimal points. If you would like to only have 1 decimal point, you can actually just delete the rest like this, and click apply and click OK. And when you try to open your mapping canvas again, and when you select once on your mapping canvas, you can see that the legend now got updated like this. Alright, so if you would like to add maybe some sort of a title, like let's say saying legend, you can select on this, go to item properties and type legend, and that will appear over here. Well, you can see that still the titles of each individual element is actually not quite presentable as a finalized map. So what I'm going to do is I'm going to rename this layer. I'm going to say elevation within brackets meters, and also these contours I'm going to maybe rename that layer as well. Well, not a proper renaming, but I'm going to sort of get rid of that underscore and yeah, put it like that, elevation contours. And this one I'm going to rename it as area of interest. Alright, now let's go back to our mapping window and see what happens when we do that. Yeah, as you can see, nothing happened because the updates have not been actually transferred from here into this our mapping canvas. So what you can do is you can simply hit update all over here, and as you can see, again it updated the changes which we did over here into our mapping canvas. Now again I might have to go back and get rid of those unwanted items like this. Yeah, I think this looks quite okay to me, except that I need to add one border for this. So you can simply add one border simply by going to this frame option, and you can simply add a simple frame just like this. Yeah, I think this is good enough. So I'm going to move this one to somewhere over here. So the next thing that I would like to do is I would like to add a north arrow. So you can go to add item and add north arrow, and maybe the north arrow, let's set it somewhere over here. And as you can see, you have actually a number of north arrows which you can choose from, but I'm just going to stick with this. I think this should be good enough. Finally, you can also add a scale bar. You can go to add items and add scale bar, and usually the scale bar will go somewhere over here. Yeah, like this. So by default, it actually has 2 divisions like this. You can increase the number of divisions simply by increase the segments to right like this, and it's in meters, so you can actually very quickly get a visual idea about the extent in terms of meters of our area of interest like this. Now once I add the scale bar, I feel like I want to move this main item of the map to a bit further up. So what I can do is I can go to interactively edit map again and move this up a little bit like this. Alright, so finally, before wrapping up, I would also like to add one more item, which is a label. And I'm going to add that label to be somewhere over here. And the label is basically my title. I'm going to insert a title, something like elevation contour map. And if you would like to move this title within the text, within the box, you can select the horizontal alignment to be center and the vertical alignment to be middle. And if you would like to increase the size, the font size, once you select on this font option, you can see that you actually have a wide variety of different fonts. I can make it bold and increase the font size as well to be maybe about 20, 22 should be okay. Yeah, something like this should be sufficient. Now for some reason actually this map looks a bit empty to me, so it would be good if we can add something to the background. And what is good to add to the background other than OpenStreetMap which we have over here? So what happens if I activate this OpenStreetMap, come back to my mapping interface, and if I try to move this map somewhere over here like this, you can see that it actually refreshes the mapping canvas. But somehow if I do this, you can see that because of the color distribution of this OpenStreetMap, the background map, it actually takes the attention away from certain items. So I would still like to retain this OpenStreetMap as a background map, but while doing that, I would also like to maybe increase the transparency of the OpenStreetMap. So you just go to OSM standard over here and go to transparency, and you can decrease the global opacity like this. Click on apply like this. I think should be okay. Maybe decrease a bit more. Apply and click OK. And now if you go back to your mapping canvas and maybe try to refresh your mapping extent, you can see that now it's actually much more pleasing, isn't it? Now I can add item which is a rectangle just as a bounding box for this map like this. Alright, after that you can go to this style option, just click somewhere over here, and from here you can select simple fill, and symbol layer type, just select outline, so that it'll actually only create the outline for us but take out the fill color, which is exactly what we want, isn't it? So I think that's about it. Of course, if you would like to make your map much more presentable, you can just play around with the other tools as well. But as an introductory tutorial, I think you guys learned a lot by this point. So in order to export this map, you can just go to layout and export as an image. I'm going to create a new folder called maps. And I will export this as elevation map, and you again have a wide variety of image formats to choose from. So I'm going to select JPEG, and after that we can click on save. From here you can select the resolution. Well, I can decrease the resolution a bit, maybe about 150 dpi, because I'm not going to actually print this map, but depending on your requirements you can actually either increase or decrease the resolution. You can click on save, which will eventually create the map for you guys. And now if I go to these maps, and you can see we have the JPEG over here, and this would be the map that we created, which we can simply pass on to someone in case if we want to share our work with somebody else. Alright, so let me go ahead and get rid of this. Alright guys, so I think we covered pretty much everything that we wanted to discuss today in this introductory tutorial to QGIS. Again, if you're a beginner to QGIS, I guess you learned quite a lot through this tutorial. Which might not be very advanced, but certainly good enough to get you started with the rest of the work that you would like to sort of do with the help of this powerful tool called QGIS. So if you do have any questions, do not forget to comment them down below. And if you did enjoy this tutorial, if it added some value, then don't forget to show your support by hitting the like button. And of course, if you haven't subscribed to this channel, click on that subscribe button so that you'll get immediately notified as soon as we publish a new tutorial. So thanks a lot for watching, guys. I'll see you very soon with the next tutorial.